Hello, and welcome to Tennessee's at-home learning series for math. Today's lesson is for all our sixth graders out there, though all children are welcome to tune in. This lesson is the 14th in our series. My name is Reggie Caruth, and I'm assistant principal here in Tennessee Schools, and I'm excited to be your teacher for today's lesson. Welcome to my virtual classroom. If you didn't see any of our previous lessons, you can find them on the Tennessee Department of Education website at www.tn.gov/education. You can still tune in to today's lesson, though it may be more fun to go back and see previous lessons since we will be talking about things previously learned today. So today we'll be learning about understanding rates and unit rates in mathematics. Before we get started, to participate fully in today's lesson, you'll need the following: paper and pencil and a surface to write on, a calculator if you have one, and you can use your phone calculator if you have it. All right, y'all ready? Let's begin.
Okay, so let's look at an example to start us out today. Looking at the problem, what is the cost of 10 bottles of fruit juice if the fruit juice is sold 4 for $10? Solve this problem any way you choose. I'm going to give you some time to solve it. Remember, you can do it any way you choose. Okay, so let's look at two possible strategies you may have used to start working on this problem. One way you might have decided to solve this problem is with a ratio table. Taya decided to tap into what we've been previously learning about ratio tables to solve this problem. Let's look at her table together. Y'all remember ratio tables from previous lessons? This is what Taya did. I want you to take a minute to look at it, and then we're going to discuss. Okay, so what did Talia do to find the cost of 10 bottles? We can divide by 2, and we see that the juice for $5 is for 2 bottles. We can divide by 4, and we see that the juice is $2.50 for 1 bottle. To find the cost of 10 bottles, we almost forgot to do that. Talia multiplied $2.50 by 10. She got the price of $25 for 10 bottles. Did you do something similar? Good. Let's look at another solution path. Let's see what Mary did to solve this same exact problem. Here's Mary's work. I'm going to give you a second to look at it. Okay, looking at Mary's work, how did Mary go about finding the cost of 10 bottles? Correct. It looks like she multiplied. Let's look closely. Mary first multiplied both costs in bottles by 2. She saw that 8 bottles cost $20. What did she multiply by next? Correct, she multiplied by 3. And then from doing that, she saw that 12 bottles cost $30. Why did she go back to 10 bottles of juice? Correct, she went back because she's trying to find the cost of 10 bottles. So since 10 is halfway between 8 and 12, she recognized that she needed to multiply the terms in the rate by the number halfway between 2 and 3. What number is halfway between 2 and 3? Correct, 2.5. So that's why she multiplied 2.5 here. When she multiplied the cost by 2.5, she saw when she multiplied by 2.5, she got 25. So now, what does her ratio table show that Mary found for the cost of 10 bottles of juice? You're right. She saw that the cost is $25. Did you notice that $25 is also halfway between 20 and 30? That's the cool noticing. We're going to use your understanding of finding equivalent ratios today to extend to finding rates.
You're probably thinking, what is a rate? Let's dig in and see. Does anyone remember what a rate is defined as in mathematics? No, let's remind ourselves. So I know that a rate is a special type of ratio that compares two quantities of unlike units of measure.
So an example of a rate is Jan saw 9 full moons in 252 days. So to write this as a rate, we can write it as 9 full moons over 252 days. So here's another example of one. My other example, it says, it took Hannah 38 minutes to run 8 laps. I can write this as a rate of 38 minutes over 8 laps. Good job.
All right, so to help you connect, you can find equivalent rates the same way that you find equivalent ratios. What were those ways? Great job. We use ratio tables, multiplication, division, and graphs. Good job going back to that memory.
We're given a racetrack where a race car travels 10 kilometers in 3 minutes. If the race car continues to travel at the same rate, how long will it take it to travel 25 kilometers? So, what is our rate in this problem? That's right. Our rate for this problem is 10 kilometers in 3 minutes. Or I can write this as 10 kilometers, 3 minutes. Let's solve this in a couple of ways to show you how it connects to what we've been doing. So one way is we can use a ratio table. So let's start off with that. So here's our ratio table. Since we're given 10 kilometers and we are trying to find 25 kilometers, we can set up each column for distance in increments of 5, which is what we did here. So 5, 10, 15, 20, 25. Now let's see how we can find our times. What operation was performed to go from 10 kilometers to 5 kilometers? So what operation was performed to go from 10 kilometers to 5 kilometers? Correct, we divided. What did we divide by? 2. So when I take 10 divided by 2, I get my 5. So we can use the same operation with 3 minutes. I'm going to take my 3 and I'm going to divide it by 2. 3 divided by 2 is going to give me what? 1.5. Good job. I can write it as this, or I can write it in fraction form, whichever way works for you. So since we have worked with ratio tables for a few lessons, I'm going to let you complete this table. We will check back in a bit. But just remember, when I went from 10 to 5, my number was getting smaller, so I divided. Now I'm going from 10 to 15. Think about what we have to do to get from 10 to 15. Will we have to divide or multiply? I'm going to give you a second. Okay, so I'm going to start filling in my table. And I want you to check your table with mine. How did you do? Good. We can use this now, the table, to find our solution. We are asked to find the time it will take to travel 25 kilometers. According to our work in our ratio table, it will take the race car 7.5 minutes to travel 25 kilometers. Good job. We can also solve this in another way. We're going to write the rate as a fraction, and we're going to multiply both terms by the same number. So I'm going to go back to here. So I know I had 10 kilometers and 3 minutes. And I'm trying to get to 25 kilometers to figure out how many minutes that will take. So I'm going to use X for my variable since that's what I'm looking for. So now we need to find a way to solve for X. Think, 10 multiplied by what number gets me 25? So 10 multiplied by what number is going to give me 25? In earlier grades, we learned that we can rewrite this mathematical sentence as 25 divided by 10, which is going to give me what? Correct. 25 tenths. Which is the same thing as or 2.5. So now let's use that fact to help us find the number of minutes. So remember, when we generate equivalent ratios, we multiplied or divided both the numerator and the denominator by the same number. This allowed us to keep the same relationship between the numbers in the ratio. Since we need to generate an equivalent rate, we can do the same thing. So now I can take what I know and I can go back to my original term, and it was 10 kilometers over 3 minutes. I can multiply this by my 2.5. And whatever I do to my numerator, I'm also going to do to my denominator. So I'm going to multiply that by 2.5. So now we have 10 times 2.5, which is going to give me 25 kilometers, which is what I knew in my original problem. Now I got to get my minutes or my time. 3 minutes times 2.5 or 2.5 is going to give me what? I agree, 7.5. So this lets me know what? It allows us to see that it would take the race car 7.5 minutes to travel 25 kilometers. Make sure to include those units as you work and respond today. So let me make sure I put my minutes. They're very important to let us know what the problem is actually saying. So the comparison of quantities with unlike units of measure is what makes these problems rate problems. Good job, y'all. Let's try another one. So we're going to build off that previous problem, and it's saying at the same rate from the previous problem, how long would it take the car to travel 60 kilometers? So what can we do to extend what we know to find this answer? Let's set up a rate fraction, the same rate fraction that we were just using in this problem. So now I want to know, what can I multiply both my numerator and denominator by to create equivalent unit rate, well, equivalent rate. So 10 times what is going to give me 60? Correct, 10 times 6 gives me 60. So remember, whatever I do to my numerator, I do to my denominator. So I can also multiply my denominator by 6, which is going to give me what? 18. So 60 kilometers over 18 minutes. So how long will the car 60 kilometers? Correct. It will take the car 18 minutes to travel 60 kilometers.
We're going to look at two ways to use a rate to represent relationships between the given units. Remember, in rates, the units are not the same when comparing two quantities, like miles per gallon or cost per ounce.
So here is our next problem. This problem says, Harvest Market sells a crate of 15 pounds of Fuji apples for $12. What are two different unit rates that could represent the situation? Again, it says, Harvest Market sells a crate of 15 pounds of Fuji apples for $12. What are two different unit rates that we could use to represent this situation? So let's remind ourselves of what a unit rate is. What is a unit rate? You got it. A unit rate compares a quantity to one unit of another quantity. Remember that? So what are our units in this problem? Correct. Our units in this problem is pounds and dollars. So what are we asked to do in this problem? You got it. Find two different unit rates that could represent the situation. So let's do this. Since our units are pounds and dollars, we need to find the same unit rate in pounds per $1. And then we will find it in dollars per 1 pound. So I'm going to give you a moment to get started and we will work together. Let's start with finding the unit rate in pounds per dollar. So we're going to start off with our unit rate in pounds per dollar. So for pounds, we're going to use the abbreviation. And for dollars, we'll use the dollar symbol. So always make sure your units are present. So we know we started out with 15 pounds to $12. To find the unit rate per dollar, we need to get a dollar in the denominator. What can we divide 12 by to get a dollar? Correct. I can divide by 12. So I'm going to divide my denominator by 12
And remember, whatever I do to my denominator, I have to do to my numerator, so I'm going to divide that by 12. Remember, the reason why we do this is because this allows us to keep the same relationship between the numbers in our ratio. So let's divide it out. I know that my denominator is going to be $1 because 12 divided by 12 is $1. And now I'm going to do 15 divided by 12, which is going to give me 1.25 pounds. So this shows us that the unit rate in pounds per dollar is 1.25 pounds per dollar. What does this mean? It means that we can get 1.25 pounds of Fuji apples for $1 at the harvest market. So I want you to take a moment to find the unit rate for dollars per pound. So now I want you to find the unit rate for dollars per pound. We're going to use the same abbreviations. I'm going to give you a second to get started. All right, so now since we want to find the unit rate for dollars per pound, how would this look different? Correct. We will now have the dollars in the numerator and the pounds in the denominator. So I know I'm going to have my dollars in my numerator and my pounds for my denominator. So now I can start filling in. I know it was $12 per 15 pounds. What does that help us find? Correct. It means that we are finding how many dollars it will cost for 1 pound of apples. So it's kind of different from the other one. So for a unit rate, we need 1 pound in our denominator. What can we divide our denominator by to get us 1? Correct. I can divide by 15. And whatever I do to my denominator, I also have to do to my numerator to keep our equivalent ratio. 15 divided by 15 is going to give me 1 pound. And 12 divided by 15 is going to give me 80 cents. So what does that mean? Correct. It means that it's 80 cents for 1 pound of Fuji apples at the harvest market. You see how we did it 2 different ways and we get 2 different answers. But it all depends on what we're finding our unit rate for. This one was dollars per pound. This one was pounds per dollars. Let's look at another problem. Our next problem, a recipe for scrambled eggs uses 2 tablespoons of milk for every 3 eggs. What are 2 unit rates that could represent this recipe? Again, a recipe for scrambled eggs uses 2 tablespoons of milk for every 3 eggs. What are 2 unit rates that we could use to represent this recipe? So, what does the problem ask us to find? Correct, it asks us to find 2 unit rates. What are the units in this problem? Correct, our units in this problem is tablespoons of milk and eggs. So what are 2 ways to use a rate to represent the relationship between tables of milk and number of eggs to a recipe? We can do it 2 tablespoons of milk, and I'm using this as my tablespoon abbreviation, to 3 eggs. Or we can do 3 eggs to 2 tablespoons of milk. Let's start with finding the unit rate of tablespoons of milk per 1 egg. So we're going to start with our first one. What can we divide 3 eggs about to give us 1 egg as our unit rate. Correct, we can divide by 3. So divide this by 3, and whatever I do to my denominator, I'll do to my numerator to keep them equivalent. This allows us to keep those equivalent ratios. So that's going to give me, when I divide 3, that's going to give me 1 egg. And then 2 tablespoons divided by 3 is going to give me 2/3 tablespoon of milk. You got that? So what does this unit rate tell us? It tells us how many tablespoons of milk will be used in the recipe for every 1 egg. So we will use 2/3 tablespoons of milk for 1 egg in this recipe. Now let's look at the next one and see our relationship here. So we're going to do 3 eggs to 2 tablespoons of milk. I want you to use what you've learned today to find the unit rate in the number of eggs per 1 tablespoon of milk. Okay, so you're right. Where do I start? I can start by dividing my denominator for this one by 2, since I know I'm trying to get 1 tablespoon of milk here for my unit rate. And whatever I do to my denominator, I do to my numerator. So I'm going to divide that by 2 as well to keep that equivalent. So 2 tablespoons of milk divided by 2 is going to give me what? Correct, 1 tablespoon of milk. And then 3 eggs divided by 2 is going to give me 3.5 eggs. Good job. So what does this unit rate tell us? So we're looking at this one. It tells us how many eggs we will use in the recipe for 1 tablespoon of milk. So for this recipe, we have eggs, or 1.5 eggs per 1 tablespoon of milk. So going back to our problem asks us to find 2 unit rates that can represent this recipe. What are our 2 unit rates? Correct. This is our first unit rate, tablespoons per eggs, and our second, eggs per tablespoons of milk. Can every comparison of 2 quantities with different units of measurement be represented with 2 different unit rates? Think about our problem. Yes, I want you to explain it for me. Good, you can compare each quantity to 1 unit of the other. Do you think this information is helpful in our everyday lives? Yes, when we shop, we want to know the best deal. This is a clear way to help us determine that. When we run, we want to know the fastest mile. This is a clear way to help us determine that. When we cook, we want to know information on single servings. This is a clear way to help us determine that. We can find many ways that the unit rate gives us valuable information in our everyday life. This is an elephant charges an object that is 0.35 kilometers away. If elephants can charge at speeds of 0.7 kilometers per minute or 7/10 kilometer per minute, how long will it take the elephant to reach the object? Use a fraction to set up a rate. Do we have the information for a unit rate? All right, you're right. We would have to make our unit rate look like this. So we can do 7/10 of a kilometer times something over 1 minute times something else to give us our equivalent unit rate. And I know I wanted to give me this, and I'm looking for my minutes. So what can we divide 7/10 kilometer or 0.7 kilometers by to get 0.35 or 35 hundredths of a kilometer? It is 0.5. And I can do the same thing to my denominator. So this will give me, in minutes, 5/10 of a minute, or a half a minute. That's not bad for an elephant. Here's our next problem. The last one we're going to do together today. It said it took Puelo 8 games to score 30 points. At that rate, how many games will it take her to score 45 points? So I'm going to give you a second to solve this. So how did you solve it? Okay, I hear that you wrote a fraction. And then I heard somebody else said they did a table. Let's look at a table, since we haven't looked at one yet. So here's our table. By looking at our table, we can see that our unit rate is 7.5 points per one game. We can also see that 15 points were scored in 4 games. I think this information is the most helpful. So if I know that 4 games, there were 15 points, how many games were there 45 points? We can easily see that 15 times 3 gives us 45. So I have to do 4 times 3, which gives us 12, which is what we had here in the table. Good job. Great work. Today we review ways to understand rates and unit rates. I hope you're seeing some connections to equivalent fractions. You sure did do a great job. After the video, you will have some problems to practice on your own. I will show you the independent practice problems now, or you can find them on the Tennessee Department of Education's website at www.tn.gov/education. Good luck, and thanks for hanging with me today. I really enjoyed reviewing rates and unit rates with you. Thank you for inviting me to your home. I look forward to seeing you in our next lesson in Tennessee's At Home Learning Series. See y'all later. Bye.